Now that we know how to find derivatives, we're going to think about how derivatives affect a graph. So we've already seen that the derivative at a point is the slope of the tangent line at that point. So that means that whenever a graph has a positive slope, the derivative is positive. So, for example, this interval right here, f prime of x would be positive there because the slope of the graph is positive. And then also from here, up to here, our slope is positive. So our derivative is positive. And then from here, the slope is also positive. And now let's look at where the slope is negative. For this graph, that would mean that the derivative is negative. So that is this line right here. The slope is negative. So the derivative is negative. And then here, the derivative is negative. And here, the derivative is negative. And then at those points where the derivative is switching from negative to positive, the derivative is either 0 or it does not exist. So here, we have a cusp, so the derivative does not exist. But here, when the derivative switches from positive to negative, the slope of the tangent line would be 0, so the derivative at that point is 0. Same here, f prime of x is 0 when the slope switches from positive to negative, and then also here, the slope is 0. And here. So whenever we have a curve where the slope switches from negative to positive or positive to negative, we would have a horizontal tangent line there, so the derivative is equal to 0 at that point where the graph changes direction, unless we have a cusp, like what happens here, unless the graph is not smooth. And then also right here, something kind of strange happens because the graph becomes vertical. So what that means is that our tangent line at that point would be a vertical line. Which means that f prime at that point is undefined. Okay, so now let's look at what's happening at these points where the derivative is equal to 0. So this point right here, where the derivative is 0, that is also going to be a local maximum. That means related to the points right around it, it is the maximum. So on a certain interval, it is at the top of the interval. It is the maximum value. Here's another local maximum. And a local minimum. So it's at the minimum of all the points right around it on a certain interval. Here's a local minimum. Here's another local minimum. So what we're going to be exploring in this module is how does the derivative affect when we're going to have a maximum or a minimum. And if you just observe from this graph, the times that we have a maximum, well, first the derivative is equal to 0. And then also our derivative is switching. As we approach the maximum, it's switching from positive right here, it's 0, and then it's negative. So a maximum is happening whenever the derivative is positive to the left of the point, 0 at the point, and then negative to the right of the point. And then a minimum, a local minimum, is happening whenever the derivative is negative to the left of the point, 0 at the point, and then positive to the right. That's what creates a minimum. Same for this point. The derivative is negative to the left of the point, and then when we pass the point, the derivative becomes positive. So those are just some of the ideas that we're going to use to build the first derivative test and to determine what's happening in the graph of a function. Also, the reason we have the word extrema here, extrema just means an extreme value. So that means a minimum or a maximum. It's just a word that means either of those.